Hi, this is Andre, and here's another update on the MicroPET. So the last time we have been looking at all the standard functionality like IEEE, keyboard, and so on, video output. So this time I'm looking at all the new stuff, which is a USB port here, the Ethernet port on top of it, on this breakout board, the SD card interface, and the real-time clock chip. So stay tuned. So this shows the demo of the USB part, and I had recorded it before, but then I found out audio wasn't working. So this is the video, and I comment it here. So let's start it. And booting the machine, and then loading the driver for the USB chip that is on there. And so what you will see is that it puts that stuff in the background. So this is actually a driver I've shown in another video on a real pad with the USB on the user port. It shows the device, shows some configuration, and then you can move them around the mouse. And then here, I think there is some integration already. So you can see the cursor moving pretty quickly, probably too quick for that particular mouse, which is a different one that I used in the other demo. And clicking the mouse gets into some issue with the pressing the return key and so on. But in the end, this shows that the USB is working. In the next demo, I will show you the Ethernet functionality of the MicroPET. I'm using this breakout board with the ENC28J60 board on the back, and I've located it here on top of the actual USB interface. So you plug in the breakout board like this, and then you put in the Ethernet card, and now let's see what we can do with it. Okay, so let's have a look at the code from the MicroIP stack, which is here. You can see it gets a connection, then sends hello, what is your name, reads in a name, and prints it out on your standard output, and also sends it back to the user. Basically a hello world. So let's move that aside and have a look what the machine does. So let's load the program. What you will now see when I start the program is a lot of kind of garbage on the top of the screen. That's some debug output that I used while debugging and will be removed in later versions, but well, anyway, that's how it is right now. So now the MicroIP stack is running, and now let's have a look and see what we can do. And for example, what you can see here now is I've run it in on this IP address. So the first one is not working, probably the ARP cache, but then you suddenly get something like there is a packet coming back. You can ping it, and then you can actually call that application that is compiled here into in the MicroIP stack. Then it says hello, what is your name? Well, I got I don't know, I think it's It's got problems with character conversion from PET to ASCII, so that's why here there's the H missing and the W is missing from the watt. Because as you can see here, this is here in capital letters, the other stuff is in lowercase letters. So then let me enter something. What is your name? Andre? Bam! You get it here. Well, kind of. It should be printed out here, but anyway, and you can also see it here on the screen. So yes, Ethernet and TCP/IP is working. The next part I'm going to talk about is the real-time clock chip and the battery backed up memory. So this is actually this very tiny small chip here. Not even sure if you can see it in that resolution. Very tiny. So it's SMD, and I had it soldered onto the board by the board manufacturing. So there is the 32 kilohertz clock quartz that drives the clock of the chip, even in all states, even when it's battery backed up by battery. Maybe you can see there is a tiny extra wire I had to connect to the CPLD, because I was missing one of those wires in the schematics, and so it was missed in the board production process. But the board that will be on GitHub is already fixed. So here we have the connector for the battery backup, but I don't have right now where is it? I don't right now have such a coin cell that fits in here or something like that, and that I can solder to that connector. So what I'm going to use is I use a bench power supply to provide the power for the backup, for the clock and for the backup memory. So let's connect it with So, yeah, so let's see what we can do. So let the machine boot. And we can see here the test programs. So if I run that, you can see it's initializing the clock, and it starts running the clock. Of course, you don't know if that is something that is really backed up by battery. But this is very easy to see. Just look at the clock as it is right now. I'm going to switch off the machine. You probably see that the power LED is completely off. The backup battery should be powered by the power supply, and then when I switch it back on again, so what we can see here is now that it's not initializing because it sees the clock is already running, and then it continues with the time, showing the time as it was before. Also, there is some battery backed up memory on there, so you can read it with a little program, and then you can enter some value here, the brown box, and then it reads the value back, and it sees, okay, this is the right value in the memory, jumps over the log, missing the A, but the A was there, I guess. Okay, so it's in there, and then now I can switch it off again. Maybe we can wait a little while, but I'm not going to show it because I mean this is battery backed up. So okay, I'm switching it on again. Looking at battery memory, backed up memory. And you can see, yeah, there is the value that I just typed in, even with the typo that I just typed in. So that's a success. SD card interface. So what I'm now going to do is take this micro SD card and put it into the MicroPET, so you can actually see what's going on here, and then you see how we can use that. So let's boot it and get us the program. Yeah. And as you can see, like all the other programs, this is just very, very simple. Not that simple, but anyway, rather simple, basic program. You can run it. You can see it's initializing the card, and then it's reading block 0 from the SD card. So then if you look at the actual output that I took from that very same SD card, you can see we have a success here, as long as we're waiting for the end of the block, which is, well, it's basic, and you know basic is slow, and I'll probably move over that. So as you can see, we have the exact same data that we have on the original SD card. As you can see from the dump from the SD card, we have that in the basic listing. I also call that as success. So this concludes the discussion of the technical features of the MicroPET. So the next step will be move it into this case. So we'll be looking into 3D printing brackets and stuff to put it in, and where to cut openings and to get that board into there, so you can really have a MicroPET into a Commodore 64 case. So I'm really looking forward to have that finally put into that case and be really presentable as some kind of new, whatever featured MicroPET. So thanks for watching.